Scientific notation was made for us to be able to write big numbers a little bit easier. For example, these numbers are not that big, but what if I had a number with like 100 zeros, for example? What if I ask you guys, what's the distance from Taft to Bakersfield in inches? Like that's a big number. So obviously, it's a lot to write. So that's why we made scientific notation. The way we're gonna make scientific notation, first of all, I'm gonna put a decimal here whenever here, such that I make my number between 1 and 10. So more than 1, less than 10. If it's I cannot do between 1 and 10. If I had to choose one of them, then choose 1. But here, I can easily do 9.3. I can place my decimal here to make it 9.3. So I'm going to do 9.3 times 10 to an exponent. I notice that I place my decimal here, but I need to move it to the right 7 places. So I'm gonna do 10 to the positive 7. My exponent, if it's positive, I mean move to the right. If it's negative, I mean move to the left. Here, for example, I'm gonna place my decimal between the 6 and the 3. So it says 6.32. Once again, I want this number to be between 1 and 10. So once again, between the 6 and the 3. So I'm going to have 6.32 times 10 to a number. I notice that I want my number to be moved to the right 10 times. So I'm going to do positive 10. Here for my example C, I'm going to do 4.62. I'm going to place my decimal between the 4 and the 6. Once again, I want this to be between 1 and 10. Times 10 to a number, I'm going to move it, this case, to the left, and I'm going to move it 3 times. So I'm going to do negative 3. Right, once again, whenever you're moving to the left, make sure you use the negative sign. Here, for my example D, to begin with, I'm going to do 7.62. I'm going to place a decimal between the 7 and the 6. I am going to include a negative sign in front of it because of the negative sign. So I have negative 7.62 times 10 to the power. I notice that in this case, I move my point, I move it to the left side, and I'm going to move it, let's see, 1, 2, 3, 4, 5. So I'm going to call this negative 5. So this is what we call scientific notation. Now, I might ask you guys to write each number in standard notation. Standard notation is the way we always see it. So you are given this in scientific notation, write it in standard. So here, if you notice, 10 to the 3, I need to move my decimal 3 places to the right. Add zeros if you need to. So notice how it started between the 6 and the 2. I moved it 3 to the right. Whenever we don't see the number, the decimal point, we assume it's at the end. So notice I moved it 3 places to the right. Once again, add zeros if you need to. Looking at my example B, I'm going to move, it starts between 4 and 2. I'm going to move my decimal 5 places to the right. So I'm going to finish with this number. Right, it was between the 4 and the 2, and if you notice, I went 1, 2, 3, 4, 5. 5 places to the right. Add zeros if you need to. Here we usually separate them by groups of 3 with a little comma, so that way we read that as 428,300. Now looking at my example C, I need to move it 2 places to the left. So I'm going to have negative 0.0973. Right, it was between the 9 and the 7, and I moved it 2 places to the left. So that's why I added an extra 0, because you add zeros if you need to. Now, when it comes to decimals, mathematically that is correct, 0.0973. But when it comes to decimals, we do like to start with the number. So you might have negative 0.0973. Mathematically, both of them are correct. Still in scientific notation, we're going to talk about multiplication and division. Now, multiplication, when we're dealing with multiplication scientific notation, multiply the 7 and the 5 the way we always multiply. 7 times 5, I'm going to get 35. I'm going to have 35 times 10 to the something. Add the exponents. So I'm going to have 10 to the 7. So what I'm saying here is, after the 5, move the point 7 places to the right. But I need to fix this a little. And the reason why I need to fix this, because 35 is not a number between 1 and 10. So I'm going to convert this to 3.5 times 10 to something. My exponent number changed. Remember, if it was after the 5, you needed to move 7 places to the right. It seems like I moved the decimal 1 place to the left. So not only I have to move the 7 places to the right, but I need to move it 1 place more, because it seems like I moved the decimal place 1 place to the opposite side. So in this case, I'm going to do 10 to the 8. Same thing for example B. Now we're doing division, right? A fraction is division. So 4 divided by 2, I'm just going to call this 2, times 10 to something. Now here, remember how I'm going to subtract this? I'm going to call this 10 to the 5 at the bottom, which ends up being 10 to the 8 at the bottom. But remember how we said if it's positive 8 at the bottom, that means is negative 8 on top. So I have 2 times 10 to the negative 8. My number 2 is between 1 and 10, so I'm done. I don't have to fix this one. Now lastly, we're going to talk about word problems. A nanometer is a very, very small unit of measure that is equivalent to about 0.0000003937 inches. About how would 700,000 nanometers measured in inches? So first of all, let me write this number in scientific notation. I'm going to do 3.937 times 10 to, I notice I will have to go 1, 2, 3, 4, 5, 6, 7, and 8. I need to move it 8 to the left. That's my nanometer number. Now, 700,000, I'm going to write that as 7 times 10 to, now here, notice I'm moving to the right, so I'm moving it to the right 5 times, so I'm going to do positive 5. All right, so my numbers, these numbers, 3.937 and 7, I'm just going to multiply them out. Just the way we always multiply numbers. 3.937 times 7. So I get 27.559. So 27.559. And I'm going to do 10 to something. I see my exponents. When I add them, I get negative 3. I'm almost done because this number is not between 1 and 10. So I'm going to rewrite this as 2.7559 times 10 to something. Remember, if it was after the 7, I have to move 3 places to the left. Notice I already moved 1 place to the left, so I only have 2 places remaining. So that should be my answer.